Hello everyone! This is problem 5-79. Consider the function defined by inputs that are the length of the radii of a circle, and the outputs are the areas of those circles. Write the equation for this function and investigate it completely. Okay, here we go. Is everybody ready? Better strap on your safety belt. We're going to be moving through this one. So, I think what this is talking about here, when we define the inputs as the length of the radii, and the outputs are the areas of the circles, we have to be talking about the formula area equals pi times the radius squared. How many people remember that? Good for you. You're on a roll. Let's keep going. So, if area equals pi times the radius squared, then if we wanted to turn this into a function, let's take our output and let's turn it into y, and let's turn our input, which is our radius, into an x. Ooh. So we have y equals pi times x squared. Oh, great job. So now let's kind of explore this function. This will be fun. Okay, so one thing that I want to do if I'm exploring is I want to kind of come up with a graph to kind of see what it looks like. I think we could do that. If our input is being squared, then we're going to have probably what would be a parabola, right? X squared. Oh my gosh. However, one thing that we're going to have to remember here is these x values are actually our radii. So I don't think we could have a negative radii in there, right? We can't have a negative distance. So when we look at this here, we're going to have to think about our smallest x value probably have to be 0. And if I plug 0 into this function, let's plug it in here. 0 squared is 0, and times pi would still be 0. So I get my output as 0 as well. Well, I'm going to plot that point on here. That point would be about right here. Now the next part here is, let's say, oh, I don't know, what if my radius was 1? Do you know what to do now? 1 squared is 1. And if I multiply it times pi, that would be pi. Okay, but pi is really the equivalent of saying approximately 3.14. Shh, don't tell. We're going to use the decimal value here. So let's go over 1 and up. 1, 2, 3. And I'm going to go, I don't know, 3.14. I say it's about right there. Okay, so let's move on. Number 2. Ooh, if my radius is 2 units long, then that means when I square it, that would be 4. And then 4 times pi is going to give me 4 pi. I love pi. It's delicious. So 4 pi would be approximately 4 times 3.14. I wonder what that is. Well, 4 times 0.14, 1400ths, that's going to end up being about 0.56. So this should be about 12.56. I checked it on the calculator already. Don't tell. Okay, so let's plot that one. So I'm going to go over 2, and then, oh my gosh, I'm already off my graph. But I'm going to put it somewhere up here. Oh, let's guesstimate. That'd be fun. Boop. Okay. So, if I wanted to kind of sketch that, we'd know that it's going to kind of go up like this. And then it's going to go up even more between the next 2. Bam! That looks a little crooked, but it's kind of got this little curve to it, and it's going up like half of a parabola. Yay! So, let's talk about it now. Well, we already said here that our radius is going to have to be greater than or equal to 0, right? Because we can't have a negative radius. That would be just totally crazy. So if we think about it here, our domain for this, well, we can't have any negatives here, so our domain is going to kind of match what our radius is. So we're going to say x is greater than or equal to 0. Smiley. Good job, everybody. The next one. Well, where there's domain, there's also range. So let's do the range here. R-A-N-G-E, range. What would our range be? Well, our bottom point ends up being down here at the origin. Everybody knows what the origin is? I'm sure you do. You're so smart. So we're starting at 0 and we're going up. So our range is going to also be y is greater than or equal to 0. I bet you already knew that. You're terrific. Next, what else do we have to find when we're exploring our functions? How about the x-intercept? I knew you would remember. What is our x-intercept here? Is it 0, 0? You're on a roll. Great job. How about our y-intercept, everyone? Is it going to be any different on this one? Most certainly not. We're going to end up with 0, 0 again, also at the origin. Holy smokes, that is just crazy. Is there anything else here that we could think of? Are there any asymptotes? That's that funny word, asymptote. In this case, there's not. All we have here is our shape is half of a parabola. So maybe we should write that. It's going to be a half a parabola. Just remember, we have a restriction on our domain because we can't have any negatives. And that, remember, is our radius value. Shh, don't tell. Great job. All right, so did we answer all the questions here? Write the equation for this function and investigate it properly. Oh, I'm sorry, completely, but properly. So we've got our formula and we turned it into the equation and we investigated it completely. So holy cow, I think we're finished. Oh, I hate being done so soon because I love visiting with you boys and girls. You guys do a great job. I'm going to give you a little Valentine's Day special. Be my Valentine. If you want to be my Valentine, please let me know. Just tell Mr. Boyd. Mr. Boyd will hook us up and you can bring me some chocolate. I love some chocolate. Okay, so problem 5-79. Everybody have a great Valentine's Day. Holla!